Hello everyone, my name is Shahrukh and I teach physics from class 9 to class 12 students, and I did my BTech in mechanical engineering, and after that I did my MTech in production and industrial engineering, and I am here to teach you physics. Chapter is ray optics from class 12th, and the chapter number 9 according to the NCERT. So let's begin with our chapter, that is ray optics. So first we will discuss what is internal reflection. So when a light ray comes from denser medium to rarer medium, what does it mean? Denser medium like water, as we know that water is denser than air. So here is water is the denser medium and air is the rarer medium. So let us consider the refractive index for water is mu2 and the refractive index for air is mu1. So when a light ray comes from the denser medium, that is water, and goes to the rarer medium, that is air, so we know that when light rays coming from the denser medium to rarer medium, then at the interface, then at the air water interface, the light ray bends away from the normal. This is the normal. So students, this is the normal, and we know that when the light ray comes from denser to rarer medium, then the light ray bends away from the normal. Light ray bends away from the normal. So when the light ray comes from denser to rarer medium, some part of it is reflected into the same medium. Some part of light ray is refracted in the air, but some part of the light ray is reflected into the same medium, that is water. So this is called internal reflection. When the incident ray, after reflecting from the interface, bends in the same medium, then this type of reflection is called internal reflection. Now let's come to the next slide, that is of total internal reflection. Now the topic is total internal reflection. What is total internal reflection? We know that the light ray comes from the denser medium. After striking on the interface of air, water, or rarer or denser medium, the light ray bends away from the normal. So here is the angle of refraction is A and angle of incidence is B. Now as we know that the light ray refracted away from the normal, so in this case the angle B is smaller than angle A, because the refracted angle is greater than the incident angle, that is B. So here incident angle is angle B and refracted angle is angle A. Refracted angle is angle A, and here angle A is greater than angle B. So if we increase in the second figure, if we increase the incident angle, if we increase the angle of incidence, that is angle B, so the stage comes when the angle of refraction, then the angle of refraction becomes 90 degree. If we increase the angle of incidence B, then a stage comes when the angle of refraction becomes 90 degree, then at that point, at that instant, the angle of incidence becomes equal to critical angle. Here angle C is critical angle. So what is critical angle? Critical angle is that angle at which the angle of refraction becomes 90 degree. And this position is also called as grazing emergence. Grazing emergence. Now in the figure 3, if we more increase the angle of incidence, here angle of incidence, here angle of incidence is angle D. If we increase more the angle of D, then a stage comes, the refractive angle becomes more than 90 degree and the ray refracted into the same medium. So this phenomena is called as total internal reflection. Again, if we increase the angle of incidence more than the angle of critical angle, then the light ray bends into the same medium and this phenomena is called total internal reflection. This phenomena is called as the total internal reflection. So let's come to the next slide. Calculation for the critical angle IC. We all know about the Snell's law. Snell's law. What Snell's law says, suppose this is the incident ray and this is critical angle C and this is the ray which is reflected into the same medium or angle of refraction. Here the medium is air of refractive index mu1 and here is the medium is water with refractive index mu2. So according to Snell's law, if a light ray coming from denser medium to rarer medium, suppose this is our angle of incidence and this is the angle of refraction. Here this is the rarer medium and here mu2 is the denser medium. So according to Snell's law, mu2 into sin I is equal to mu1 into sin R. Mu2 sin I is equal to mu1 sin R. Then we know that at critical angle, if we put the value of angle of incidence is equal to C, that is critical angle, then angle of refraction becomes 90 degree. Angle of refraction becomes 90 degree as we have discussed in the previous slide. So now put the value of I and R in equation 1. In equation 1, so here mu2 sin I is equal to mu1 sin R, then mu2 sin C is equal to mu1 sin 90 as the angle of refraction becomes 90 degree. So we have put the value of r equal to 90 degree. Now mu2 sin c is equal to mu1 into 1, as the value of sin 90 is equal to 1. Now sin c is equal to mu1 upon mu2. If here the rarer medium is air, then the value of refractive index is equal to 1 if the medium is air. So sin c becomes 1 upon mu2, and mu2 is refractive index of denser medium. Refractive index of denser medium. So here we can easily find out the value of critical angle if we know the value of refractive index of the denser medium. So this is the method to find out the value of critical angle. Suppose the denser medium is water. Suppose the denser medium is water, and in case of water the value of mu is 1.33. Now put this value of mu in the equation 2. We get sin c is equal to 1 upon 1.33. After calculating, we get sin c is equal to 0.75 and c is equal to sin inverse 0.75, and the value of c becomes near about 48 degree. Now by this method we have calculated the value of critical angle. So students, in this topic we have discussed first the internal reflection, second what is the total internal reflection, the third one what is the critical angle, and finally the calculation of the critical angle. I hope you have understand all the topic and all the concepts behind this topic. So we will discuss the next topic or next things about the same chapter in our next lecture. Thank you very much.